The next operation is insertion in a binary search tree. Generally, insertion is nothing but adding a new node with a given value at the correct position in the binary search tree. Why? Because to store the data elements in the binary search tree, there are constraints, right? In a binary search tree, always the value of the left node must be smaller than the parent node and the value of the right node must be greater than the parent node. So, this rule is applied, right, recursively to the left and right subtrees of the root. So, without violating the rule, we are supposed to insert the value at the correct position in the binary tree. Adding the node at the correct position is nothing but the new node should not violate the properties of binary search tree. Let us see now how to perform insertion in a binary search tree, and these are the steps given here. The first step is begin at the root node. Always we are supposed to start from the root node and compare the value to be inserted with the current node's value. Always the value which you want to insert needs to be compared with the root value. If the value is lesser than the root node, recursively insert it into the left subtree. Suppose if the value is greater than the root node or parent node or whatever, recursively perform insertion into the right subtree. And after traversing to the right subtree or left subtree, finally you just insert the value at the position where the subtree becomes null. Finally, when you look for searching for a right position, if the value if the subtree becomes null, you just insert the value at the position. Let us discuss the example now. Create a binary search tree using the following data elements. These are the data elements given. We are supposed to perform insertion now with these the provided data elements. The first step is you can begin at the root node, which means you can start from the first node. First node is going to act as a root node here. Now, the very first node is 47, which means create a new node. Step 1, insert a node, data element 47. Yes, created the new node and inserted 47 into it, and there are no, currently this is acting as a root node because initially the tree was null. After inserting this, there will be only one data element in the tree and the left field and right field would be null, which means since it does not have any left node and right node, the left address field, because this tree data structure can be implemented only using doubly linked list, right. So, if you check the left address field, it is null, and the right address field, it is null, because there is no left node and right node currently, right. Now, the second data element is 41. You compare it with the current node, which is the root node. Since the data element which you want to insert is coming lesser than 47, definitely it would fall in the left subtree only, right. So, look at the left child. Since there is no left child, the list becomes null. Insert the value at the position where the subtree becomes null. If I look at the subtree, it is null only, but it should fall under the left subtree only. So, now since it is null, you create one new node as a left child for the parent 47 and insert here. If you look at the third data element, that is 58, that must come since it is coming greater than the root node 47, it must come in the right subtree only, right. 58 is greater than the root node, somewhere in the right subtree only it should fall. So, next it would look at its right child. There is no right child, you can create a new node and insert 58. Next data element is 13. Compare it with the root node. Yes, it is coming lesser than it, so it should check in the left subtree only. Again in the left subtree there is a node 41. Now again compare 13 with the 41. Since it is coming lesser, look at the left child node. There is no left child node. Create a new node and insert 13 here. Then again, next data element is 36. Compare it with the root node. It is coming lesser than the root node, so left subtree only. Check again in the left subtree, there is 41 is there. Compare 36 with 47. 36 is coming lesser than 41 only. Somewhere in the left subtree only it should be. And then again there is a 13. Compare 13 with the 36. Since 36 is coming greater than 13, it should act as right child for 13. Next data element is 80. Compare it with the root node, it is coming greater. So, in the left hand side only somewhere. Again in the left hand side there is another data element 58. Compare 58 with 80. Again 80 is coming greater than 58 only, which means 80 should act as a left child for 58, right. So, left child is null. Create a new node and insert 80 there. Next data element is 34, compare with the root node. Since it is coming lesser than the root node, check in the left hand side. Again there is 41, compare 34 with the 41, it is coming lesser only, and go to the left subtree since it is lesser. Again in the left subtree there is a node 13, compare 13 with the 34, the value which I want to insert. 34 is coming greater than 13, somewhere in the right hand side only 34 should come. In the right hand side if I check again, there is new element which is 36, compare again 36 with the 34, it is coming lesser than 36. So since it is coming lesser than 36, this 34 must place somewhere in the left hand side of 36 only. Look at the left child node is completely empty, so create a new node and insert 34. The next data element is 11, check with the root node, it is coming lesser only. Look at the left subtree, again in the left subtree 41 is there, compare 41 and 11, 11 is coming lesser. Since it is lesser, look at the left child of 41 and the left child is 13, 13 and 11 if you compare, 11 is coming lesser. Since it is coming lesser, this 11 should act as the left child node of 13 only. If you check left child node is completely empty, create a new node and there you can you can insert a new value 11. The next data element is 91, compare it with the root node, it is coming greater, so in the left hand side, in the right hand side only it has to, you have to check. In the right hand side again one more parent node I have, that is 58, 91 is coming greater than 58, so again right hand side of 58 you have to check. In the right hand side of 58, 80 is there, 80 and 91 again if you compare, 91 is coming greater. Since it is greater, if it is greater you have to place in the right hand side of 80. If you check right hand side of 80, it is completely null. Since it is null, you create a new node here, insert 91 and connect these two. The next data element is 55, compare it with the root node, it is coming greater. So right hand side of the root node only you have to check. The right hand side again at the next level 58 is there, 58 and 51 you compare, 51 is coming lesser than 58. If so, 51 should appear at the left hand side of 58. If I look at the left hand side of 58, it is completely null. So create a new node and insert 51 here. The next, 55, right? Yeah, insert 55 here. And the next data element is 69, which is coming greater than the root node. If so, I have to check in the left hand side only. In the left hand side again there is another node, compare 58 with the 69, it is coming greater, so it should come in the right hand side again, since it is coming greater. In the right hand side there is one more node, that is 80, compare 80 with the 69, 69 is coming lesser than 80. Since it is coming lesser than 80, the 69 should fall under the left hand side of 80. If I look at the left hand side, it is completely empty, which is null, so create a new node and insert 69. This is how we are supposed to insert a new node. And if you want to insert one more data element, that is 83, again compare 83 with the root node, it is coming greater. Since it is coming greater, look at the right child is 58, compare 58 with 83, again 83 is greater. Look at the right child again, since it is greater, compare 80 and 83, again 83 is greater. Look at the right child again, since it is greater, again in the right hand side there is 91, compare 91 and 83, 83 is lesser than 91. If so, it should fall under the left hand side of 91 only. If you look at the left hand side is null, so create a new node and insert a new node 83. Now if you look at it, yes, it is satisfying the property. If you look at all the elements in the left subtree, it is it is coming lesser than the root node only. If you look at all the elements in the right subtree, yes, all the elements in the right subtree is coming greater than the root node only. We have satisfied the properties, and this is how we are supposed to perform the insertion operation. Now let's write the pseudocode for performing insertion. I will write here this side. Pseudocode for performing insertion operation. The first step is, if the tree is completely empty and the element which you want to insert is going to act as the very first element. My tree is completely null. Initially the tree is empty. If the tree is empty, the first step is allocate memory for the root node. Tree is nothing but the address of the root node. It indicates the root. during the first iteration 47 would act as a root node. Then suppose if you are traversing towards its left, the left child node again during the second iteration the node 41 would act as a root node, that is current tree. So every time at each level each parent would act as a root node, that is tree, which means under the tree the parent node's address would be passed. If the tree is completely null, allocate memory for the tree, allocate the memory for the root node, for the new node, and set tree is nothing but root node's address. Root node's check is set in the place of tree's data. You can write the value which you want to insert newly, and since it is doubly linked a list, after filling the data field you are supposed to fill the left field as well as the right field, right? Left field would hold the address of left node and right field would hold the address of right node, right child, right? After filling the data field you are supposed to fill the left field as well as the right field. Since 47 was the very first node I have inserted into the tree structure in the binary tree, after inserting this 47 there was no left child node and right child node, so initially this would be having null. If my node is the very first node, after inserting the first node left field and right field would be null right after inserting it. So set tree left and tree right equals to null if the value which you want to insert is going to be the very first node, else there are already nodes there. For example, I want to insert data element 94. If so, the new data element 94 I want to add, because the node which I want to insert is not acting as a very first node. Already there are elements. You take this example tree structure, there are already data elements. Now I want to insert this new data element 94 into the existing binary tree structure, binary search tree structure. If so, it would go to the else part, and we have to check if the value which you want to insert is lesser than the tree data, root data. Compare it, 94 is lesser than the root data, no. Root data is 47, the value which I want to insert is 94. 94 is not lesser than the tree data which is 47. Tree is what? Root node's address, root node's data field you have to check. Root node's data field has 47, 94 is not lesser than. If it is lesser, we are supposed to call, sorry I forgot to mention the function name here, insert tree value. This is the function, this is the function name. If the value is coming lesser than the tree data, I am supposed to call the insert function towards its left child node, which means I am going to perform insertion at the left hand side only. I am going to check trees left. So if it is lesser than the tree structure, if it is lesser than the root node, it is supposed to call this recursive call this function recursively, and in the place of tree the left node's address in the current, suppose if it is lesser, this address of this left field must be passed in the place of tree, and the value which you want to insert, that is 94, would be passed here. Else my value is not lesser than, right? If so, I am supposed to perform insertion at the right hand side of the root node. So trees right comma value, which means I'm going to call this insert function, and in the place of tree I am going to pass trees right. Trees right means the right address of the right, for example right address of what, the node 58 address must be passed here in this tree, and the value 94 which I want to insert would be passed. So it would keep on recursively call like this, and finally when the tree is found, when the position is found, which means when the tree is equals to null, because while inserting the position would be null only, right? You will keep on checking it. After checking it, finally when if the tree is null, which means if here the left child is completely null, allocate a memory, create a new node in which you can insert a new value, that is 94. Recursively you call a function. Finally when the tree becomes null, in the null place you are supposed to create a new node, allocate a memory, create a new node. In the data field you insert a value, and in the left field as well as in the right field you can add null, because since it is acting as a leaf node, there is no right node as well as the left node, right? This would be having null. So recursively it is going to call the function and it would be inserting the elements, the data element in the appropriate position. After inserting it, end all the functions, end of if, and finally end the pseudocode. This is how it would perform the insertion operation. Let's trace the pseudocode once again. Here the value 94 I want to insert, right? First, this is the function, insert function. Tree is nothing but the root node's address, value is nothing but the value, the new value which I want to insert into the binary tree. First, check if the tree is equals to null. Check this example, check whether the tree is equal to null. Tree is not equal to null because we have taken this tree as an example. Tree is not equal to null. If it is equal to null, you allocate the memory. If it is not equal to null, you would go to the else part and check the value which you want to search is lesser than the root node's data. Root node's address is what this tree is. For example, root node address is AA. AA's data field it is supposed to check. In the place of AA's data field 47 is there. Compare 94 and 47 whether 94 is lesser, no. If it is not lesser, again go to the else part, which means it is greater, right? Go to the else part, call this insert function, insert trees right, since it is coming greater. If it is lesser, we are supposed to look into the left subtree. Since 94 is coming greater than the root node, which means we are supposed to look at the right subtree, right? So it is supposed to traverse to its right child node. Right child node's address would be stored in the right field of the current root node, right? So in the place of tree, you are supposed to pass the address of right child. For example, if this is BB, right child's address is BB, address BB would be stored in the tree's right field, right? So tree's right field address must be stored here. So here BB would be passed. Now after calling this function again, now the tree address is BB. Whether BB is null, no, BB is not null. So if BB is not null, because in the place of BB some other value is stored. If the BB is null, directly in the place of BB you can insert a new value. Since the address location BB is not null, check again, you just compare BB's data. Now compare the value which you want to insert with BB's data. BB's data is what? 58. Check again, 94 is not coming lesser than 58. Go to the else part again. In the place of, go to the else part and call the insert again, and in the place of else part, because since it is not null, again you compare. In the place of trees right, in the place of tree you are going to call trees right because it is coming greater again. If so, definitely since it is coming greater than 58, it would fall in the right hand side of 58 again, right? So the 58's right field address must be passed. For example, the address of 80 is DD. DD would be stored here, right? Since it has to go to the next level and check. It has to check the current BB's right field. BB's right field has what? The address DD. So while calling this recursive call, in the place of tree, this tree right would be passed. Tree right is nothing but DD. Now check DD is equals to null, no. In the place of DD again there is a data. If so, come to the else part, check DD's data. DD's data is 80, again 94 is not lesser, go to the else part, call this insert function. In the place of tree, you are going to call current trees right. Current tree is a DD, DD's right must be passed. DD's right is going to be this 91 node's address, right? For example, the address the address of the data element 91 is stored under EE, means EE would be stored here, no? So here current tree is what? Current tree is DD. DD's right is going to be EE. So in the place of DD, EE would be passed. Check here, E is equals to null, no. Again there is a data element in the place of EE, that is 91. You compare. E is data field, current tree is EE, E's data field is what? 91. Again 94 is not coming lesser. If so, go to the else part. Now in the place of trees right, in the place of tree you call trees right. Tree is EE. EE's right is, I want to insert 94. E is right was null because there was no right subtree, so E is right is null, so E is right would be passed null. So here E is right is null. Check now whether the tree in the place of tree we pass the null, whether tree is equals to null. Yes, tree is equals to null. If so, allocate a memory, create a new node. In the place of data field you write the value which you want to insert, which is 94, and in the place of tree left and tree right you place null, because there is no right node and left node, right? So every time when you create a new node, ensure that you are filling the data field, the left field as well as the right field. When you perform insertion, always in the left field and right field you will be placing null only, because after performing insertion, finally wherever we find the null places, in the appropriate place, we will be inserting the new data element. Once the new data element is inserted, the left field and right field of it would be having null until we insert the next element. That's it. So this is how we are supposed to perform an insertion operation in a binary search tree. Thank you.